homework for a whole week off there?
It's okay.
Looks like you just put the homework for the whole week up there.
I don't know if I have it all, but I can try. This is Thursday.
She's currently writing the homework from Thursday and tonight's homework on the board as well because we will be going over it on Monday, not today.
43.
Hi, Jimbo.
No.
I hope, buddy.
Sorry, I cleaned up as fast as I could. She hasn't even started yet.
I mean, all we've done is I took my bag open, put my bag closed, and through my nose, I put lipstick on, or actually lip gloss.
Yeah, lipstick. I was gonna say. I can't imagine you sitting here being like, red, nice big red lips. This is not what
Everyone put stuff in
This was last night.
Yes. This is tonight, I'm telling you.
Oh.
They're new.
She's like this. Asking happy. Yeah.
Oh my god.
Where was it? Ascend. Do you ever get annoyed?
Yes.
By Corey.
You just seem like you don't let anything get to you.
Not too much. I get over my kids sometimes, but 3-year-olds can be annoying. I mean, it's not 3. 5-year-olds can be kind of annoying. Or like my 1-year-old, he's like whining, and like I have my like sweatpants on. Am I taping? Hi. And like will not let go, and all of a sudden my pants are around my ankles. Like that's annoying.
Nice.
Not in that kind of way, actually.
This is a really awkward turn.
Taboo. See, it's Friday.
At least everything was caught on video and not half.
No.
Yo, Matt, what are you doing today?
I had a dream last night that me and Watson and O'Neill were together singing "We're the 3 best friends that anyone ever had." We're the 3 best friends.
Were you running yesterday? Plugged in.
Yes.
I called your name. I called your name. I called your name.
So I showed?
No, I didn't. Was that I Mind You? Was that song you're singing? Okay. I was running hard and like really working at it actually. I changed my running routine. I now only run 3 days a week, but each of them I do like a workout instead of running.
Like just jogging.
Yeah, so I don't do any that's just like easy. It's hard.
Really, it's kind of cool.
Just out of curiosity, do you tan?
Do I tan?
Yeah, do you go tanning? Okay, I saw somebody who looked very much like him go into the tanning booth next to me.
Why were you at a tanning bed?
Alright,
I wasn't, I went next to him.
You let him finish. I would have heard that.
Stop assuming things.
I'm just messing. I thought it was
Maybe I just like to get a little color during the winter, alright?
There's nothing wrong with me.
That's not even vitamin D. Cancer bites. Biting your pet. Here's something like
Alright, let me just see.
I wish there was a capital R in my name.
red. I know some people really hate the red, but
Then why don't you change colors?
these markers seem to last longer, so the other ones are like all wearing out.
Maybe the
Oh,
market
that's
seems to
another
last
one.
longer because no one used the red.
What?
Because no one uses the red. Maybe that's why it lasts so long.
Probably.
Zach, can you get my pen?
Alright, so if you have been absent, it's been a little intense. The beginning of series and stuff, so it's, you know, it's a lot to catch up on, but videos will get you there. So today might seem a little confusing. So yesterday we talked about how to write a series, and everything we did was geometric. And more specifically, we talked about how to write one based on its terms, and kind of looking at the terms to figure out how to write one, or taking a series we already knew and replacing the x's with whatever my new r or x is, and getting a new series from that. So this is another third technique on how to write a series, and it's kind of cool. So let's say we have to write a series for this. The natural log of 1 plus x. Write a series. Obviously this one is totally different than anything that we had yesterday, because at least with the stuff we had yesterday, even when we had, like, don't write this, but x over 1 minus 2x, you knew that a was the number on top and r was the number subtracted from 1. So you could use that to write that geometric series where here's my first term, and then I multiplied by 2x and 2x and 2x to get all of the rest. But this looks nothing like that. So I really can't pick out my a and I can't pick out my r from this. But what you can do instead is this. You can realize, and I know this is going to seem a little bit out there, that we know what the series looks like for 1 plus x. And we also know what's the integral of 1 over 1 plus x. The natural log of 1 plus x. So if we can find a series that we know that if we take that series as integral, we get to what I'm trying to actually write a series for, I can take the series 1 over 1 plus x, and let me write down like what it is. So I wrote these from yesterday, like a recap of some of them that we found.
And then integrate all the terms.
Yeah. And 1 over 1 plus x is 1 minus x plus x squared minus x to the third. I'll write a couple. Dot, dot, dot. And it's the series n equals 0 to infinity. And this was the one that alternated, so it was -1 to the n and x to the n.
What would be the notation on it? Would it be that thing? I forget what it's called.
Wait, what?
What's that? The summation.
This
What's it
sigma?
called?
Sigma?
Yeah. So would it be sigma, something integral, all that?
No, it won't. So, since we know that 1 plus x looks like this, and we know that the integral of 1 plus x, or 1 over 1 plus x, is the natural log of 1 plus x, I can integrate each of these terms and get a whole new series of terms. So the integral of 1 is x. The integral of x is x squared over 2. The integral of x squared is x to the third over 3.
Bless you.
Bless you. X to the third is x to the fourth over 4. And there's probably enough terms to get my pattern. This is going to be kind of hard to integrate, although I guess we kind of can. To get that general term, I'm used to trying to just figure out what it should be. N equals something to infinity. I'm going to have a fraction. I'm going to have x on the top to the what? Let's say we go x to the n and we start n at 1.
X to the n over n.
Does that make any sense? And can I just put it over n?
Yeah.
But negative.
Oh, I gotta do my alternator too. Okay.
Mhm.
I gotta go -1. Can I go to the n?
No.
No.
No, I gotta go to the n -1 or +1. Either way, to make the powers work. So let me just make sure that works. So if we
Yep.
plug in 1, we plug in 2, 3, 4, and 1, 2, yeah. There's our series. How cool is that?
Not cool at all.
It's kind of cool.
It's really calculus coming in.
Yeah. So what's hard is, yeah, it's okay. What's hard is realizing that this is the integral of one that we already know. But it's always going to be somewhat simple. Like they're not going to give you, some crazy integral that you've never seen. Like you can kind of say, okay, these are the few that I know. The derivative or integral of them is something I can now use. So that's where that comes up. Let's do another one. You got that one all down?
Just think, can I get a drink?
Mike!
Come on, please.
Of course, I don't care.
Man, don't yell at us.
I have to yell at somebody.
Yeah, let's
We get corn.
No.
See ya.
Write a series for arctan.
Oh, let's see.
So stop and think about arctan for a minute.
1 over 1
And-
plus x squared.
What's that?
1 over 1 plus x squared.
1 over 1 plus x squared. Don't we know that, which way does it go? That
The
the
derivative.
derivative of arctan is 1 over 1 plus x squared. So I know 1 over 1 plus x squared, I know the series for it. Am I going to take the derivative of it or am I going to integrate it?
Great.
Integrate it.